Se há coisa que aprendemos nos filmes é que os aeroportos são sempre locais bons para um reencontro romântico. Sim, até no assalto ao aeroporto com o Bruce Willis. Lembram-se daquele abraço no final, enquanto neva e ecoa uma música de Natal? Querem mais romântico do que isto? Outra coisa que aprendemos nos filmes é que a inteligência artificial está de facto cada vez mais desenvolvida. E se algumas ficções parecem exagerar no que toca às possibilidades da inteligência artificial, a realidade prova que não. A inovação tecnológica já substitui a ação humana em muitas funções e não falamos apenas da automação de fábricas ou operadores automáticos de telemarketing. A humanoide Sofia imita mais de 60 expressões faciais, dá palestras, entrevistas e até já entrou em anúncios de televisão. Na Estónia, aposta-se no projeto de um juiz robô para julgar pequenas disputas legais. Os robôs há muito que auxiliam médicos e enfermeiros, incluindo em blocos operatórios. A cirurgia robótica é uma realidade também aqui no nosso país, em Portugal. De acordo com uma notícia de 2017 da revista brasileira Exame, entre as profissões que poderão ser substituídas por robôs até 2030, encontram-se recrutadores de recursos humanos, assistentes jurídicos, repórteres, jornalistas e pilotos. Durante grande parte dos voos, os aviões já são controlados por sistemas computadorizados, mas empresas como a Swing realizaram já voos de teste completamente autónomos. Mas nem só de pilotos vive o setor, como sabemos. Construção das aeronaves, controle das mesmas, check-in, serviços prestados pelo pessoal navegante, carregamento de malas e mercadorias, até ao próprio controle de tráfego aéreo. Tudo pode ser feito por sistemas digitais. Por outro lado, não imagino um robô a dizer: "Boa tarde, senhores passageiros, daqui fala o comandante T300A2. Por isso mesmo, eu vou estar atento ao próximo painel, cujo tema é a utilização de inteligência artificial pela aviação. Para apresentar os oradores e moderar a conversa, passo então a palavra à Magda Cocco, sócia responsável pelo setor aeroespacial e pela área de ICT da Sociedade de Advogados Vieira de Almeida. Olá, bom dia.
Bom dia.
Magda, seja muito bem-vinda. Uma boa conversa, está bem?
Obrigada.
Obrigada.
Bom dia a todos, bem-vindos. Eu vou fazer esta primeira introdução em português, mas depois vamos fazer o painel em inglês. Queria só dar-vos as boas-vindas, dizer que, como a Catarina referiu, este é um tópico extremamente relevante para quem trabalha em toda a cadeia de produção, digamos assim, em todo o ecossistema da aviação e também espacial. E vou, sem mais delongas, apresentar aqui os nossos convidados, que penso que vão trazer um enorme valor. Começo por pedir para se dirigir ao palco a Inês Berlenga, que é Project Manager for Ethics in AI na EASA. Inês? Bom dia, bem-vinda. Depois o José Freitas, da Aerospace and Security Sales Manager na Edisoft. E finalmente, bom dia José, bem-vindo. E finalmente o José Neves, Board Member na GMV. So now I will switch to English. Good morning to everyone. It's a pleasure to have you here. We are today discussing a topic that is extremely interesting, and we have around 45 minutes to discuss this topic of AI in the aviation and aerospace sectors. Before giving the floor to our first speaker, I would just like to do a small setting the scene. I have some slides for you, just for slides to let you know a bit how is AI in this context. We have already, Catarina has already highlighted the benefits of AI in the aviation system. And when we talk about AI, we are talking also about data. So data and information availability, boosting productivity, dynamic pricing, security, and other services. There are many applications that can be used, and Catarina also highlighted this, many applications that can be used in this context. Just to give an example, there are those more traditional and more from a management point of view, and there are also others that are more related with the aviation activities, such as fuel optimization or flights or fraud detection. In terms of the legal environment, and I just want you to have a general overview, there is much to be considered. I will not go into detail on this, but it's important that you know that this technology and also the underlying data that is used with AI, because we don't have AI functioning, and the purpose of AI, the food, let's say, for AI is data, is subject to intensive regulation in Europe in particular. And therefore, you have here some examples of some of the regulations that are being discussed in Europe. So you have a specific regulation that covers the AI products and service, product-based and service. You have also extensive regulation on data and the regulation how we can use data, how public entities can use data, and how private companies can access to public data. So there is huge regulation at the European level on this. And we have also important, in terms of regulation that must be considered in this context, also intensive cybersecurity regulation. Just to give you some highlights of the legal framework. And now, Inês, I'll give the floor to Inês. I know that you have a video to show to us.
Yes,
okay?
Thank you, Magda.
So if you could...
So maybe we can jump into the video first.
In just a few years, aviation has developed brand new facets. New business opportunities are taking off in the field of urban air mobility. For instance...
O som está muito baixo.
Well, I don't think we have the video. We have the sound, but even the sound, I think it's not very loud and clear. Maybe we can do a small adjustment.
So Inês, while we are waiting for the video, could you just briefly explain your role in the agency and in this specific domain of AI?
Sure. In fact, the AI program in the agency, in EASA, it's a beauty because it comes with several different players from different departments. So, in fact, you can find me in EASA in the International Cooperation Department. But in fact, on the AI program, I participate on the ethics, so I'm the project manager for this part. And I have several colleagues also from other departments, so it's kind of an horizontal program. Mm-hmm. And that's basically where you can find me in the agency.
Okay, great. I don't know.
And I think we have the video ready to go, right?
Yeah, go.
Let's try it then.
In just a few years, aviation has developed brand new facets. New business opportunities are taking off in the field of urban air mobility, for instance, with the development of drone products capable of delivering goods, or with the deployment of air taxis in urban environment that we can expect in a foreseeable future. Aside of other technological innovation like electric propulsion, the recent technological breakthrough in artificial intelligence and deep learning is one of the main drivers for the unprecedented wave of innovation we are facing in urban air mobility. And those are just some examples of what artificial intelligence can enable today. So imagine what it can do in all other domains of aviation. In air traffic management, for instance, it can be used to optimize departure and arrival trajectories or to bring advanced assistance to the air traffic controllers. In maintenance, it can be used in support of augmented reality tools or for the analysis of a massive amount of health monitoring data in view of a more predictive maintenance. In aerodrome operations, it can be used to optimize ground operations or for the detection of birds or even drones. AI is an enabler of a peculiar nature that serves multi-domain applications. This is what led EASA to dedicate the roadmap to the main question: how to certify AI-based solutions when they are related to aviation safety.
And that's it for the video. Okay, so actually, Magda, we were speaking about doing a bit of an update of the AI roadmap of the agency.
Yes, that
Yeah.
will be interesting because I mentioned in the beginning that there is this European regulation that is applicable to all sectors. It's still being under discussion, it has not been approved, but will have an impact in all industries across different sectors, so mainly also aviation, let's say. And EASA has done a very important job in trying to think in advance what will be the impact of the work that has been developed from a legal perspective and from regulatory perspective to the aviation industry. So I think it will be very interesting for the industry to know what is this roadmap and what are you proposing.
Okay, lovely, yes. Yeah, in fact, in 2020, EASA launched what we call this AI roadmap that, as you were saying, we're actually preparing AI trustworthiness framework. So how can we rely on the systems that are popping up now applied to aviation? So we intended to launch a big, mature framework that could give support to all the domains in aviation that are actually related to AI systems. Of course, focus always on safety. So this was the goal of the roadmap. So we launched it in 2020. So from then until now, lots of things were actually happening in the agency. So we actually prepared ourselves to give guidance, to draft a concept paper that will be the basis for the industry to foresee what the regulation will become. Mm-hmm. So, but you can ask me, so what is this framework about? And basically, we have 4 building blocks. There are strong assets for this concept paper. So, of course, trustworthiness, it's important. We do the assessment in terms of safety, of security, and this novelty, which is actually now ethics. But the 4 building blocks are very important. And starting with the first one, we can always start with actually learning assurance, which is actually to see if the systems are delivering what we expect them to deliver, if they are performing as we expect that they are performing. So in fact, we have this logic of a 2V, which is actually W, yeah. Which is basically the first part of the V. It's like linked to training. So it's everything that is linked to data management, to labeling, to training, to verify the training of your system. And then when you have a very good verification and your model is more or less settled, then you enter on the other part of the V, which actually for implementation. So how can your model be implemented? And of course, you verify continuously because you want to be sure that everything turns out as you planned. So this is actually the first building block of the concept paper, learning assurance. The second one, it has to do with explainability. Okay, we developed the systems, right? But we have to do a very good explanation of what is happening, yeah? So here, of course, we link this part with human factors, and we are focused now on the people that are actually conceptualizing the systems, developing, implementing the systems, but the challenge will be also to think about how to explain this to the people that will work with the systems at a later stage. So basically, this is the second building block. The third one, it's related to ethics, which is really a novelty, right? So all of this has to do with our judgment about these new systems. So, and ethics, it's really a challenge. What did we do? In fact, first, we tried to see, we started with actually the AI level group from the European Commission, so they issued what we call this ALTI, which is basically a huge set of questions, ethical questions, and we analyzed question by question. So we'll try to link the questions to the technical part. So in the technical part, how can we ensure that this is safe in terms of ethics analysis. And for the questions that were not explained by the technical part, that what we did was like, okay, checking on the European regulation, what links could we actually have? So, for example, for data protection, we all know about this topic, so it's very easy to link this question to the regulation that it's already issued. The beauty of this thing is that for all of the other questions that are ethics-based, but it's not actually explained neither on one side for the technical part or the regulation, we have actually to create a new gears, new ways to reply. And this is now actually also a big challenge for the agency, for the group. It's not so easy when you talk about, for example, of non-discrimination matters or societal questions or even democracy. We can say, okay, what is this to do with aviation safety? And simply we can say, well, it's not on the remit of the agency, we don't have anything to do with it. But in fact, EASA, it's an European agency and we have responsibilities toward this. So we are trying to work on the best reply to the ethics part. Mm-hmm. And of course, the fourth pillar, the fourth building block of this concept paper, it has to do with risk management. Of course, just for the residual risks, because we don't want to deploy anything that is related to any criticality. So basically, in a sum, these are the four building blocks that constitute the concept paper that we issued in 2021. This was the first usable guidelines that gave a bit of a good flavor of what the regulation will be in the future. So we are now, of course, we issued for consultation. We had lots of good inputs from, I bet, more than 20 partners. Mm-hmm. So all of these inputs were really well worked, and we took into consideration all of these inputs. And of course, in line with this, we also have lots of different projects. But in fact, we are prepared now to launch the second issue of this framework with a more mature draft. And we expect to launch it on the first semester of the next year. Mm-hmm. So this is the goal. And of course, you will see, if you have the possibility to read the concept paper, that the first focus was actually on what we call AI level 1, yeah, which is basically AI that assists the human. It's a bit like augmented reality. But the second issue that's going to be launched next year will be also not just the augmented reality, but also into AI level 2, which is human and machine interaction and collaboration, which is a step forward, right? So this second issue of the guidelines will also be linked to this. The third level, which is kind of more linked to the autonomous machines, will be for the future in 2024. That's what we expect.
And you expect, I read the concept notes, of course, and according to your roadmap, you expect these third fires to come in 2024, 25, around that?
Yeah. So for next year, level 1 and level 2. Uh-huh. So human augmentation, so human assistant and human-machine interaction and collaboration. Mm-hmm. And further on, 2024, 25, let's see. More into these autonomous machines.
Autonomous machines.
Yes.
This is just to give you a comparison. This is much like the automobile industry that has the same different levels. In their case, it's 5 levels. The same levels of integration of autonomy in the vehicles, the vehicles. So now, this is very interesting what you said. I think there are some aspects that I really think it's interesting, but I will come back in the second round of questions, because now I would like José Freitas to talk a bit about how do you think that AI can contribute for a more secure and sustainable air transportation sector?
Okay. Well, thank you very much, Magda, for the introduction. I would like to salute my fantastic panel colleagues and all the people who are attending here or in the internet. plus the City Hall for this magnificent event. Okay, so I come from Edisoft, which is a Thales Group company. We have a stand G04, please visit us. And artificial intelligence is really a very key aspect for us. Mostly, Magda, I think you put the whole menu over there of where things can fit, so I'll try to pinpoint that. So the artificial intelligence, by its concept, is nothing new. So it started off in 1950s, and it led to, let's say, more automated response for the for computer system. But really, the breakthrough is when you start to get more data, and data communicates, especially when it's there is no so much delay, so sometimes real time, and then new algorithms start to develop. One thing important, I think, is since we are all, or most, engineering or technical companies, is to demystify to the whole community what is AI. So people on one side think of AI as unpredictable algorithms, sometimes like Facebook, Google Analytics, that are taking jobs and adding more risk and causing more crashes. So what you don't understand is hard to accept, that's clear. So the potential for AI in aviation is untapped, for sure. EASA groups, Eurocontrol groups, they have been doing, these are public reports, we participate in some of these work groups. They've identified where are the risks, where are the lags, areas to improve. I will give a few examples of when, on a day-to-day basis, where improvement can be achieved. First, regarding the green aviation, it sounds like a kind of European or Brussels buzzword, but it's not. Traffic patterns have changed considerably. Just think about Ukraine. It basically closed the whole airspace going to the east. So many airlines, especially ones that are EU flagged, have to fly westwards to reach Asia. So now the whole thing is a bit different. So the patterns change. This is important for the airlines and for the air traffic navigation service providers. So predicting traffic, the flows, analyzing all this can lead to even small improvements on routes, flight planning, even the type of aircraft, and can lead to small saves that at the end make a lot of money. Alaska, for instance, did some analysis with AI for their flights, and they could prove that they could save 4% costs on just little optimizations. One other thing is security. I mean, we all think as security as something boring, but I can give you an example. How many of you have entered an airport? They went to security line, you had kids and stuff, and then a bag is diverted to be inspected, and there was only a mobile phone charger that looked sharp, and they'd ask if it was and then you see all your bags pile up, and the kids just stop, and this. So we are developing a product which will be certified in 2023 called Helix View. So it's a fully automated scanner. You just put all your objects, don't have to take anything, nor laptops, nor anything, and it will do a 3D scan, and the artificial intelligence will be able to tell the security operators what is really the threat, and will obviously learn, and they will cross-feed them. So the time that you lose taking stuff out or false positives will be reduced, and the other way around. New threats will be easily enforced. This will save a lot of time at the airports. Then, again, so AI is based on data. So without data, you have no different from the, let's say, conventional ways. Actually, the human is great, collecting data from different sensors, making some quick decisions, but this can be improved. People think, can we have airliners that are fully automated? Can we have UAVs flying cargo across the pond? Well, answer is, well, let's not think it that way. Let's think AI as a tool for better decision support, not to fire people or to reduce risks. Because some airports you cannot fly with any instruments. It's a pilot looking at their eyes, not just because of run. So the point is to give them better decisions or better information for decisions. But as of today, not in the future, we're using AI on our flight management system. It's called Pure Flight. So it will be the basis for it has been chosen by Airbus to equip the next next aircraft. We use AI not in the FMS, but to test the FMS. Because FMS is something, well, you don't want to screw around with data, so you don't want to deviate 1 mile away. And it's something that the pilots put their trust in, so it will navigate you to the right place. So what we did, we always do to certify this kind of equipment, there's a very stringent procedure to develop, test. There are standards like DO 178 VC, and we must cover all possible test cases, but these test cases are thought by humans. Huh? So it's the humans thinking of where could this fail, what kind of use case could be there, and you shouldn't patch this thing on a day-to-day basis. Huh? This is a equipment that's on board the airplane, you can take it, you can patch it, but it's not something that you update. And it's really one of the brains of the plane. So what we did was the other way. We used artificial intelligence to test the system. So we went one step further than the, say, battery of tests, which already exists, but we tried to test things that no one would have thought of. And we generated, to certify pure flight, 2 billion test cases. So we put the equipment through that, and that was the equivalent of 100 million flight hours. 100 million flight hours.
Fantastic.
I mean, an aircraft sometimes, if it's well properly maintained, probably reaches the end of life with 30, 40, maybe 100,000 flight hours if it's, but nothing more. So we had 100 million flight hours. Then, there's a topic of cybersecurity. That's the point, because as soon as we use AI, it comes part of mostly on the digital transformation of ATM systems and so on. Cybersecurity becomes more problem. It's a problem today, but if you can interfere with systems that are not so deterministic, it's even worse, because you can corrupt the data. So the data is everything for artificial intelligence. You typically, what you do is process a larger amount of data that is different, and a human eye, let's say, cannot poke into it and say things are wrong. So it's a part of, let's say, an environment. What we're doing is design things that are, develop systems that are cyber secure by design.
By design.
So, the moment they're designed, they're already cyber secure. And this involves a great deal of, we have what we call a company, we have a DVA, Design Validation Authority, any new product, any new system. This must be analyzed by a product line team, and now the cybersecurity is applied at Thales Group for any kind of product.
Yes.
Applied the most. For the ATM side, so there's also the route optimization, where airlines will be more obviously concerned with revenue, so spending less and charging more. The ANSPs will be more focused on obviously being part of an economically feasible ecosystem, more minded towards the optimization of the resource, which is the air as a transportation mean, but also reducing risks. So it's more complex to put, safety systems on board an aircraft. On the ground, it's not so critical. For instance, at Heathrow Airport, they were doing a system with video-based to check if an aircraft vacated the runway or not, which is very important. Airports that you can't see. We had almost an accident the other day at the Azores, so an airline almost landed with a car on the runway. They were 150 meters away from crash. There was another aircraft that's known that had a motorcycle strike. So all this stuff could have been deadly.
AI could be very important in this case as assistant. Thank you, José Freitas. Now, I want, in the next round of questions, I would like to know a bit, because you talked about that you are concerned with the design of IA products, and this is a very important aspect. And I want to know how Edisoft is tackling these ethical changes and so on. But now I just want to know from José Neves, also the same. What are you doing in GMV in this field? And how do you tackle this ethical and also at some point the regulatory aspects of AI?
First of all, good morning. Thank you very much for the invitation. It's for me always a great pleasure to contribute to the growth of the Air Summit. I have to tell you, Magda, that first I have to be very careful, because after Katarina setting up a great scene of what is AI in aviation, you've talked about regulation, Inês talked about the roadmap, José Freitas gave wonderful use cases of application of AI. Let me go to the beginning. Aviation has always been a front runner in terms of innovation. I have in front of me a person that used to work for Embraer, and he knows much better than ourselves what aviation has done for other business of activities or lines of industries, like the introduction of ABS systems, comes from aviation, was used in motorbikes, and then move on to cars. AI brings a third revolution to aviation. We had in the 50s the introduction of jet engines, we had in the 80s by Airbus the introduction of fly-by-wire, and now we're reaching a new revolution in terms of how aviation behaves. It's a revolution in terms of the technology. It's a new technology which brings, and Inês mentioned, huge challenges, and also brings new business models. In the video was talking about air taxi, so urban air mobility. On my perspective, urban air mobility is only to be a broad market if AI is used in the aircrafts. So you take out the pilot and replace the pilot by what I call the holy grail of AI in aviation, which is the usage of AI in autonomous flights from its core. But AI is now being introduced to the aviation, not only because it's becoming more modular, and we have concepts here of space, weight, and power, which allow the introduction of new technologies. We have more computational power, we have new algorithms, we have more sensors, we have more data to process, and AI really brings this benefit. But brings, as I mentioned, the challenge, and Inês really tackled one point that I would like to highlight, which is how do we certify the introduction and AI in aviation? It's a huge effort. How we are going to define the process and the methods that will enable this introduction in terms of autonomous flights. And this is really recent. Inês was saying that the roadmap is going to be released by early next year. I've belonged to a working group of G34, working group in Aerokai 114, which has been created, these working groups have been created just in 3 years ago, 2019. And really the goal is really to setting up the scene on how we are going to define the rules. Inês mentioned the V versus the W model in terms of the development of the software. It's a huge change. How we are going to tackle the data that is being fed into the system. And I will give you an example. If you're using AI for autonomous flight and you're using visual data, how the model is going to behave with shadows, how the model is going to behave with clouds. Because you can simulate everything. We have projects on that domain, namely one project which is going on with EASA, which is safe term. And coming up from the pratice model, which uses synthetic data, to real life, it's a huge change. And we have to be careful, because if there's one element that defines aviation, is safety. Not security, safety today. So we don't want to mess around with that, and that's the first step. And EASA is here, so I have really to be careful. And you being a lawyer, I also have to be careful.
You learned the lesson.
And let me go back up to our experience working with EASA and working with our partners. So we have a project called Safe Term, where we really went to tackle how can we use AI to go a bit broader. We have a kind of a use case, which was we have a drone aircraft flying, we use the communication link, and we use the Murphy law. So if we lost the communication link, something else is going to happen. And in this case, a structure of the aircraft is affected, so the aircraft cannot anymore land on a predefined airfield that was defined in the beginning of the flight, but it has to land by itself somewhere. And of course, as we're talking about safety, we have to avoid casualties on the ground, we have to avoid casualties on the buildings, and of course, if possible, on the aircraft. So we incorporate data coming from optical data, infrared data, we process the data, we define what is bodies of water, what is forest, what is a road, what is a building, and while the aircraft is about to land, in real time we process the data. What is the challenge here? Is really how the model behaves with different inputs coming from the environment. And the environment is changing every moment. We think we are in a road and suddenly there's a kid crossing by. How the model is going to behave. And then how we can use this use case to also stimulate the process of developing software and systems for the future. And this, we have to be careful because AI is going to play not in a brand new system, it's going to use legacy systems on the fly. So we have to all tackle that into consideration. So these discussions in terms of the working group, which also involve EASA, is really how we tackle the technology and how we make this merge between technology and standardization, which is how we are going to then exploit this to the future. And this is very important for us, for Thales, which is, okay, we're researching, we're making investments, but in which year we believe we are going to use, we actually have AI in autonomous flights. And I see there in the audience José Marcelino, he works in urban air mobility, and of course he wants AI to be used broadly, but it will take its time. And I think I was not alive yet in the 50s when there was the introduction of the jet engine, but every time we have a revolution in aviation, things take time. And of course we have, let's say, the leverage of introducing technologies. We have the investors putting lots of money in these new kind of mobility systems. So there's a big pressure on the engineering side. But EASA help us also on the technology side, saying, come on, we have to go step by step to see how we really can measure this and how we really use all the safety nets to avoid any mistakes in the future. Because one accident can really take down the technology.
Yeah. This gives me a great opportunity to ask a question to Inês. What is the current status of AI system certification?
Whoa. Okay, thank you. Yeah, very pertinent topic. For
Definitely.
Sure. Yeah, so this is very interesting to observe. Of course, the timing of the industry is totally different from the timing of the regulation, right?
Definitely.
But we have to, live together. So in fact, yes, we already at the moment received half a dozen of products, of applications to be certified already. So, and the regulation is not yet out, right? So, but we cannot just stop and wait for the regulation to be out. So that's why we have these concept papers, and we have people in the agency working along these use cases and these new products. So in this case, for the certification in particular, as we certify products, in this case, we have a special condition on the CS23, in this case applied to general aviation, that supports these new applicants, yeah? And of course it takes a huge amount of effort because it goes case by case at the moment. But yeah, we are trying to do our best to support the industry in order to have a strong, mature base of products to be certified.
Thank you,
That's the
Inês.
status.
Thank you. Now, José Freitas, Inês talked about, and this is really important aspect of the AI technology, ethics. Ethics has been a question since the onset that this type of matter has been discussed in a regulatory matter. So what type of decision? For those who are not so familiar with this type of technology, we know that we have different levels. If we are talking about machine learning, it's much controlled by humans and so on. But when we reach a level where human presence would be minimal, deep learning and other more complex ways of introducing AI, how are you preparing your engineers at Edisoft or Thales also to incorporate a bit these ethic issues about AI? Because this is really challenging. When I work much with engineers as well, and EASA is doing a great job trying to educate, and one of your objectives is educate and incorporate these ethic aspects and all the others that you mentioned in the projects. But our private companies, and I will ask you the same question, how are private companies addressing these? Are you training your engineers? When you design the new technology, do you think about what could be the impacts of that technology? What difficult issues in terms of ethics and business would impact in that technology?
Well, yes. So in general terms, I would say that we have the internal, so the corporate ethics. We have the product ethics, let's say compliance, and we also help customers think on this, in these topics as consultants. I would say the autonomous vehicles, as José and Neves were saying, is a whole different problem because you're actually passing the control and decision to a vehicle. So liability-wise, it's a whole different matter. This works first. We have to work together with entities like EASA to work, not wait for regulations to come out and try to certify. So this has to become. We must help you with developing certifications. At the end, things will plug in. So corporate-wise, we have laws and governance model. We have everyone is trained on the ethics, and this covers a bit of everything. On our products, so we know that many of our customers are obliged to comply with many laws like GDPR, Decreto-Lei 65/2021. I know, no point saying this in English. And we actually provide consultancy to the customers, and even aviation. I can't name them for obvious reasons, but provide consultancy so they develop their own strategic information management plans, and the systems, the security operations, all that stuff. And we focus obviously on the security of information. This is I would say generally wise, we adopt engineering zero trust policy. Zero trust means that you trust your system because you designed it, and you mistrust everyone else that interfaces with or manages it. This means then authentication, data protection, and so on, endpoint security, security operations center, ISO 27001, this kind of stuff. And this is really important because, and again, I will be more general. What cannot happen is that people think, well, UAVs should have their own cybersecurity. EASA just puts regulations. Airlines shouldn't we be worried about if they have leaks on their data and visa, stuff like that. The airports should be concerned if they have their doors shut up. And the air traffic management systems if they're not shut down or misuse that. There was Catarina actually mentioned the Die Hard, which is Assalto ao Aeroporto, Die Hard 2, and the terrorists actually tampered with the ILS and made the aircraft crash. That's not so possible, but then the use case is. So I think it's important is all these entities think that they have an integrated world. So some of them actually are on the same facilities.
It's a complex,
So
ecosystem.
the point is that they should work, and this starts this goes from the design, the systems, air, ground, and there's the legacy part. So you cannot replace all that stuff.
And GMV, how is GMV tackle all these challenges, not only about ethics, but also explainability and security, and how are you tackling these topics?
Ethics is really in the cornerstone of our development, and ethics should be developed from requirements up. So when we make the requirements, when we make the design of a new system, of course, ethics has to be on the ground base and on the baseline requirements, let's say. As José was mentioned, something that we have to tackle for the future because we do not know the impact. So far, an aircraft used to be a closed box. There was no communication between the ground and the aircraft, and the systems were somehow contained in a shell. Right now, we're introducing the concept of cloud. We have more and more CPDLC communication, so we introduce even the possibility of a cyber attack on the communication link. So, as such, if we do not define any new system considering ethics as important as learning assurance, as Inês mentioned, as explainability, we're going to miss a component of what's going to be the future implementation. I do not see so much ethics on the element of certification, but I see as a huge impact of an exploitation of a new product. So of course, it's something that is considered ground up from the requirements up to the implementation and validation of the system before it's actually placed on the field and delivered to the clients.
Okay, thank you. We just reached our time. It was perfect, exactly. It was quick, but we just reached our time. Thank you very much. I think it was a great panel. I would propose an applause for them.
Thank you.
Because it was really fantastic. Thank you so much.
Thank you.